Now, with all the things we covered thus far in the course, it's now time to practice a bit. We're definitely not done with TypeScript. There are more things to explore and more things we'll cover in the course. For example, how we can combine TypeScript and React. But for the moment, it's time to take a short break and practice some of the things we learned about in a little demo project. Now, in this module, we'll work on this project together, but I definitely encourage you that you occasionally hit the pause button and try the next steps on your own. Of course, following along is also great and nice, but you might learn a bit more if you also try things on your own before you then compare your solution to mine. And with that, let's dive right in and practice working with TypeScript. For that, attached you find a starting project, as we saw it multiple times in the course already, a very trivial project with a basically empty index.html file and an empty app.ts file. And here we're going to build a small little demo application, a little project. Now, the app we're going to build will not be too complex, but it will be a nice application where we essentially will be able to manage a couple of projects, where a project essentially is a goal, you could say, so that we have lists of projects, and we'll have two lists of projects, an active list and a finished list, and we'll be able to drag and drop items from one list to the other and stuff like that. Now, of course, the application itself will be nice, but the most important thing is that it will allow us to practice many of the things we learned thus far, and that's, of course, the goal of this module. Now, also one important note, for this module, I'm going to write all the code in one single file, in this one single app.ts file, and this, therefore, will become a very, very big file. In the module after this module, I'll dive into that problem and show you how TypeScript allows us to split this file. But for the moment, since we don't know this yet and thus far we had no size issues, let's focus on our demo application. And for that, we'll actually start by working on the index.html file. Attached, you find a new file. Download it and replace all the content in this starting index.html file with that downloaded file. And do the same for app.css. There we have no file yet. Simply add the file which you find attached to this lecture to your project next to index.html, because there we also import it. So what's going on here in these files? In the index.html file, we're importing the app.css file for some styling and the app.js file for some JavaScript logic. Of course, we're not going to write any JavaScript code like this. We're going to write code in app.ts, but that will get compiled to a JavaScript file, of course. Now, in the body of that HTML file, you find a couple of template tags. Template tags are default HTML tags supported by modern browsers, which allow us to specify some HTML code which is not loaded immediately, which is not visible immediately, which is not rendered immediately, so to say, but instead which can be reached via JavaScript and therefore also via TypeScript to then render it when we want to render it, to control it with JavaScript and TypeScript. And there you see I have a form with 3 inputs, basically, a title, a description, and a people input, where we can decide what the title of our project is, what the description of our project is, and how many people can be assigned to it or should be assigned to it, and then the Add Project button. Then we have another template, which just holds a list item that will be used to render a single project in our list of projects, which is then this template here. There you see I have a header with the H2 section and then an unordered list. And indeed, that unordered list will later hold multiple single projects based on this template, which will render the data entered here through the form at the top. And everything will then be appended with the help of TypeScript to this div here with the ID app. Now, app.css just holds some CSS styles. You can, of course, look through that. I'll not focus on this here since it has nothing to do with TypeScript. And now it's our job to write some TypeScript code, which in the end fetches whatever the user enters here. Well, actually, first of all, which renders this form, then fetches whatever the user enters, validates what the user enters, so that title, description, and people has valid values, listens to a click on this button, or to the submission of the form to be precise, then creates a new project, so a new JavaScript object in the end, which is stored in some array probably, where this array is then rendered to this list, and of course the entire list also needs to be added to the DOM. So these are all the steps, and of course these are quite a few steps. Now, if you're feeling very confident, of course, definitely take this as a chance to pause right now and try implementing this on your own, no matter how it looks in the end, that you just have a setup where this form is visible, where users can enter something there, and where for every project you enter something, you render a list item in this list, which also should be visible. If you reach that, that's already amazing, but of course we'll also implement this step by step together. And thereafter, once this is implemented, we'll also make sure that we actually render two lists, and we can switch projects between these lists with drag and drop and so on. So first things first though, let's get started. To get started, here I'll run npm start to bring up that development server, which serves the HTML file, and in a new tab, tsc-w to start TypeScript compilation in watch mode, so that our app JavaScript file is continuously rebuilt, and we can view it in the running application. Right now, of course, our application doesn't look too fancy, it's an empty page. So to get started, there are many ways of doing that. Now, I want to start with making this form visible. And now there are many ways. I will actually write this application in an object-oriented approach, which is 100% optional, but since we learned about classes and so on, I want to actually show how this works, and therefore I will use this approach. So in app.ts, I'll add a new class, and I'll name it project input, though the class name, of course, is entirely up to you. Now, in this class, our goal has to be to get access to this template and to the form in it, and to get access to this div here, and then render our template in that div in the end. So the content of the template, the form, in that div. That has to be our goal. Now, to achieve this here in project input, I'll add a constructor where I in the end want to get access to my template and to the place where it should be rendered. And for this here, I'll add two properties on the fly with this, the template element property, and then also the host element property. The names are 100% up to you. In the end, my idea is that host element holds a reference to the element where I want to render my template content in the end. And well, template element gives me access to the template that holds this content. Now, to get access to that template, let's have a look at index.html and see how we can identify the template which holds the form. Well, it has this project input ID, so that looks like a good strategy. So here we can use document get element by ID project input. This gives us access to this template element. Now, a couple of important things. Here we get an error that template element is a property which does not exist on project input. Now, to get rid of this, we actually should add it as a new field here directly in the class, and then we can safely assign to it. Now here I also want to be clear about the type which will be stored in there, and that will be a HTML template element. This type is globally available because in the tsconfig.js file, I added the DOM as a lib, and that adds all these DOM types, all these HTML element types as TypeScript types to the entire project. Now, this introduces a new error here, however. You see that in the end, this could be null. When we get the element by ID, of course, we know that it won't fail, but TypeScript has no chance of knowing this because it's not going to analyze our HTML file. So maybe no element with this ID exists, and therefore this would yield null. Now here we say we don't store null in there, we just store a HTML template element. So to eliminate this danger, we have to tell TypeScript that this will never be null. And you know how you can do this? You can add an exclamation mark here. An alternative, of course, just to also show this, if you would not be sure, is to store this, let's say, in a constant, and then check if template element is truthy, so if it's not null, and then store it inside of that if check here. Now we're still getting an error, but that will be a different error, which I'll come back to later. For now, this would do the trick if we're not sure. Now here, however, I am sure, and by the way, if you're not sure, you should provide a fallback in the else case, of course. But here I am sure that we'll get such an element, and therefore we can simply add an exclamation mark thereafter to tell TypeScript, all good, we will get access to an element with that ID. Now, as I mentioned, we still have another error though. Property content is missing in type HTML element. The problem here is that we're telling TypeScript that we're going to store a template element which is of type HTML template element. And indeed, that will be the case. Now, of course, getElementById doesn't know which element it will return eventually. It just knows it will be some HTML element, but not which specialized version of it. If it's a div, a paragraph, a button, or like in this case, a template element, getElementById has no chance of knowing that. So in order to tell TypeScript about the type, which we of course also know with certainty, we can use typecasting. You learned about this as well. There are two syntaxes you can use. The angle brackets at the beginning, and then the type you want to cast this to. With that, you're telling TypeScript, hey, the thing, the expression coming after this here, this will be of that type. Or alternatively, you add as HTML template element, which is the approach I will use. And with that, you guarantee to TypeScript that what you fetch here will not be null and will be of this type. A lot of talking about selecting this, but it is a common task and it is important to get this right. Now let's continue with the host element. Here we should also add host element as a field, and we know that the host element where we actually want to render our project input will in the end be this div here. That's where I want to render my form. So here we can say HTML div element. That's the type of element we're going to add this to. We could also be a bit less specific and just say HTML element, because here I really don't care whether it's a div or not, but since we know it with certainty, why not add it? Now, I want to get access to that div, of course, where this should be added. And if we have a look at the index.html file, we see we can identify this div by the ID again, the app ID in this case. So now back in app.ts, we can use document getElementById one more time and reach out to the element with the ID app. Now we have the same problems as before. This can be null, so we have to add the exclamation mark because again we know with certainty that it won't. And getElementById doesn't know that this will be a HTML div element, so we should cast this here as well. And with that, we're now fine and we got access to all the elements we need to. Well, there was a lot of talking about that. With that, unfortunately, we haven't achieved much. We have access to these elements, but we're not rendering anything there. So let's continue with that. For that, we need to import the content of this template element. So basically import what's inside the template tags and render this to the DOM. We can do this right here in the constructor because my idea, and of course that's just my idea, you could set this up differently, but my idea is that when we create a new instance of this class, I immediately want to render a form that belongs to this instance. So I will do it right in the constructor. There we can get our imported node or imported HTML content or however you want to name it, which we can get with document import node. And that is a method provided on the global document object. And to import node, you pass a pointer at your template element. So this template element in the end, or to be precise, not the element, but .content there. Content is a property that exists on HTML template elements, and it simply gives a reference to the content of a template. So to the HTML code between the template tags. Import node also takes a second argument, which defines whether it should import this with a deep clone or not. So all levels of nesting inside of the template. And I definitely want to do that, so I will provide true here. Now we have the imported node. And as you see, this is of type document fragment, which TypeScript assumed or inferred automatically. Now we can use that imported node. And of course, I want to use it to render some content. For that, I will add a new method, a private method, which I'll name attach. You don't need to do that. I just want to split my selection and rendering logic. Inside of attach, I will reach out to the host element, so the place where I do want to render my content, and call insert adjacent element, which is a default method provided by the browser in the end in JavaScript to insert the HTML element. And insert adjacent element, first of all, takes a description of where to insert it. So there you can insert it after the beginning of the element you're targeting, so right after the opening tag of host element, before the beginning, so before the opening tag, before the end tag, or after the end tag. And here I will go for after begin to insert it right at the beginning of the opening tag. And then the thing I want to insert is my imported node. However, first of all, that's a constant only available in the constructor. And second, that's a document fragment. We couldn't insert it like this. Instead, we need to get access to the concrete HTML element in there, which we can store in another property element, which we also have to add as a field up there, which can be of type HTML element, or in our case, actually, we know it will be inside of the template here, so it will be a form. That's the first element in that template. So here we can say it will be a HTML form element. And then here, this element is equal imported node first element child. And now we just have to tell TypeScript again that this will be a HTML form element. Now this element is now the concrete property that points at the node we want to insert. So down there in insert adjacent element, we insert this element here. And now we just need to make sure that here in the constructor, at the end of it, we call attach, so this private attach method, so that this code also executes. And now with auto formatting, this is how my finished code looks like. So that now is the project input class. And theoretically, when we instantiate it, it should render the form. Now let's give it a try. Below the class, let's simply create a new constant, purge input, for example, name is up to you, and call new project input like this. And if we now save that, it should recompile and reload. And if you go back to the browser, indeed, you should see that form here. So that's pretty neat, because with that, we made our first very important step. We have our form rendered. And even though a lot is missing, that's better than nothing. This form is coming from the index.html file, and it's rendered with the help of our object-oriented TypeScript code up there. So we rendered our first form, but what you'll notice is that the styling is a bit off. I mean, the form looks okay, but some distance between the edges of our screen and the form would be nice. If you dive into the app CSS file, you'll actually detect that there we have a user input ID selector where we do add some margin and padding. So that doesn't sound too bad. So actually what we can do is in app.ts, when we create our element here, or when we get access to it, we can reach out to the element and add an ID here, which should be user-input. This will make sure that the rendered element has this ID, and hence if this reloads, this looks much nicer. If we inspect this in the browser DevTools, we see the ID here, and that's the reason for this better styling. And with that, we're already doing the next step. We're interacting with the element. Now, this is not the only interaction I want to do. Since we have a form here, I want to get access to the different form inputs we have here so that we can read the values when the form gets submitted, and that we also then set up an event listener here to the submission and validate the user inputs. So we need access to the button or to the form overall to listen for the submission, and to all the input elements to get the latest values from there. For that here, before we attach everything, but after I assigned my ID to the element here, I want to get access to the different inputs in that element, in that form. And I want to store them as properties of this class. So I'll add more fields up there. And the first field could be a title title input element field. The type will be HTML input element, like this. And we'll not just need it once, we need two other similar fields. We need a description input element field, which is of type HTML input element. And we also need a people input element field. Now we can populate these fields here in the constructor with this title input element, which I set equal to this element, so to our form element. Always keep in mind, that's the form element here. Query selector, and then query for the title element. And if we again have a look at index.html, we see in there we got the ID title on this element, so we can query for that. So in app.ts here in the query selector, we can use hashtag title to select for the title ID element and store that in title input element. Now, as you know, just as with document get element by ID, TypeScript has no chance of understanding that the query selector is going to return input element here. So to tell TypeScript, I will again use casting and cast this to an input element. And then we can repeat this step twice and also assign the description input element and the people input element, look up the appropriate IDs in the index.html file, which are, surprisingly I guess, description and people, and add them to TypeScript. So here we're searching for the description ID element and here for people. And with that we got access to all these elements inside of our class here, or inside of every object that is created based on the class. Now we just need to add a listener to our element, to our form. For that, I'll add another private method, configure, which you don't have to add, but again, I want to keep that separation where we basically do the selection and rough setup in the constructor, and then the insertion or the fine-tuning in separate methods. And in the configure method, my idea is to set up an event listener. So here we can reach out to this element, which is the form, and add an event listener. Now, since TypeScript knows that element is a HTML form element, it actually offers us auto-completion when we want to listen to the submit event here, which is great. Now we just need to bind this to a method, and for that I'll add another private method. Private because I'm never going to access this from outside of the class, only from inside, which I'll name submit handler. Name is totally up to you. This should be a method which receives an event object though, because we'll bind it to this event listener. So here we can point at this submit handler. Now we just need to make sure that before we attach, I also call configure and execute this private method. Again, it's private, so from inside the class we can of course reach it. From outside we would get a TypeScript error. So now this method should trigger whenever the form is submitted. In the submit handler, I therefore want to get access to my different input values here and validate them, and then of course do something with the inputs. Now we'll worry about the do something part later. For now, let's just get access to them. For this, first of all, I will call event prevent default to prevent the default form submission, which would trigger an HTTP request to be sent, which I don't want here. And then, just to see whether this works, let's print console log this title input element value to print what's currently in the title input element. If we save that, you see it compiles with no errors, so that's looking good. And if we now go to the console here and enter hello and click add project, good is that it didn't get submitted, bad is that we get an error. Cannot read property value of undefined. Now what's going wrong here? The problem here is that this keyword in submit handler does not point at the class actually. Why? Well, because of the way JavaScript and TypeScript works. We bind the method here to the event listener, and when we bind something to an event, or with the help of add event listener, then that something, so that method, which is going to get executed, will have this bound to something else, in this case, to the current target of the event. So this inside of this method will not point at the class when the method is triggered upon an event with add event listener. Now, the workaround or the solution is to actually call bind here on submit handler to pre-configure how this function is going to execute when it executes in the future. And the first argument we can pass to bind then is actually what the this keyword will refer to inside of the to be executed function. And here I pass this, which means this inside of submit handler will refer to the same thing as this refers to in this context. And since we call it in the context of configure here, which we call with this configure, this inside of configure will refer to the class, and thanks to bind, it will therefore also refer to the class inside of the submit handler. So if we now save this here, and we reload and I enter hello here, you now see hello gets printed here when we submit the form. So now this is solved, and now we're dealing with this properly. But maybe there is a better way or an alternative way we also learned about, maybe one using decorators. So here's your chance to again pause this and try solving this binding with decorators, because that's something we did learn about in the decorators section. I'm talking about a decorator which we can add, which automatically binds the this keyword so that we don't have to call bind here. Now, obviously, calling bind here is not a big thing and there's nothing wrong with it, but we also want to practice what we learned. And if we have to do this in many places across our app, having a decorator which we just can add might actually be easier. So let's get rid of bind this here, and instead, above the class here, I'll add the auto bind decorator. And I'm just adding some comments here to keep this file organized, at least a bit. Project input class. So, what is a decorator? A decorator is a function, right? And you can define it either with the function declaration here or as a function expression. So here I will use a function declaration and I'll name it autobind. Name is up to you. And this decorator will receive 3 arguments. The target, the method name to which it is bound, because I'm going to create a method decorator here, and also the descriptor of that method. Property descriptor, because methods in the end are just properties which hold functions. Now, why is this a method decorator? Because the idea is that we can add it to submit handler like this and be done with it. That's the idea. Now, we're not entirely there yet, but this is how it should work in the end. Now, to make it work, let's go back to our function up there. And what has to go into the function body then? Well, in there, I first of all want to get access to the original method with descriptor.value so that we store the method which we originally defined. Then I want to create my adjusted descriptor here, which is an object of type property descriptor actually, where configurable should be set to true so that we can always change it, and where we then need a getter. And in that getter here, which should be executed when you try to access the function, we will set up the bound function here by using the original method, which we're extracting up there, and calling bind this on it. Then I want to return that bound function, and that should be all. And overall, of course, I will therefore return the adjusted descriptor in that method decorator. Now we get an error with that on the submit handler that experimental support for decorators is a feature which basically needs to be enabled. So we should go to the tsconfig file, and in there, if you scroll down, you should find that experimental decorators option. Just comment that in and add a comma in front of it, save that, and then restart the TypeScript compilation process. Now, it still shows me some errors here. If I expand this, the method name is declared, but its value is never read in app.ts line 4. And it's referring to this here. I got this argument which I receive here, which I actually never use. Same is true for target. I never use that. Now, there are two ways to solve this. The one way is to go to the tsconfig and loosen our strictness rules. Here, no unused parameters. If we set this to false, we're actually allowing unused parameters. So this would be one thing. Or you use special names, underscore, and underscore 2. This actually is a hint for TypeScript and JavaScript that you're aware that you're not going to use these values, but you need to accept them because you need the argument thereafter. If you now save this, this compiles without errors. And if we go back and enter hello here and submit this, it still works now thanks to our autobind decorator, which hopefully also shows that this decorator can have some real use. Now, of course, here it's actually a bit more work than just calling bind, but imagine this being used on more and more methods which all have to be bound. Not having to call bind this manually can then really save you some time and also prevent some potential errors in cases where you just forgot it. So we're able to gather our title input value and print it to the console, but of course that's not ultimately the idea. Instead, the idea is that we gather all our input values, quickly validate them, and then do something with them. For that, I'll add yet another new method, another private method, because I'm only going to call it from inside the class. And that's the gather user input method. Name is totally up to you. My idea is that this method gets called here. After we prevented the default, this should basically reach out to all our inputs here, gather the user input there, validate it, and then return it. So that here I got my user input, which could be a tuple with the title, the description, and the people as the three tuple values. Actually, I like that idea. So let's already define a return type here. The return type is a tuple. Now, do you remember how a tuple is defined, how the type of a tuple is defined? It's not string square brackets. That means you're returning an array of strings. Instead, I want to say that I return an array of exactly X elements of exactly these three types. And for that, you set the return type here to square brackets, and then inside of the square brackets, you add the different elements and element types. For example, string, string, and number. With that, you're saying this method here returns a tuple which has three elements, where the first element is a string, second element is a string, and the third element is actually a number. And now we can add some logic to this method to make that become true. So for that, let's first of all get the entered title from this title input element dot value. And we can repeat that. We also want the entered description, of course, from this description input element value, and the entered people amount, or just the entered people, from this people input element. Now I store this in constants so that I don't always have to repeat these longer expressions. Now we can validate this. A trivial validation would be to check if entered title, trim, so removing excess white space at the beginning and end, length is equal to 0, or if entered description, trim, length is equal to 0, or if entered people, trim, length is equal to 0. That would check that no input is empty. Now, it does not check everything we might want to check, though. We are not checking whether entered people is, let's say, a positive number. We're not able to set a minimum length. We would have to add more and more conditions here, and whilst we can do this, this would not really be a scalable solution. If we have our parts in the application where we also want to validate user input, we always have to repeat long if statements. So I will come up with a smarter validation solution or a more scalable validation solution soon. For now, we can leave it like this. You can already think about this though, and of course after this lecture here, pause and think how you could outsource this into a separate validation function which is configurable, and how TypeScript could help you there. There are definitely many possible approaches, and I will share mine with you in the next lecture. But before we make it there, let's actually use this trivial approach here and do something if all these conditions are satisfied. Now, if we make it into this if block, we know at least one validation failed, and then we could throw an alert where we say invalid input, please try again. Else, if we don't make it in there, we know we do have a valid input, else I want to return my tuple. So here, I want to return the entered title, the entered description, and also entered people. Now, as you can tell, though, TypeScript is not happy, because entered people should be a number, not text. And actually, everything you extract from the value property of an input element will be text by default. So to turn this into a number, we can call parse float, for example, or simply add a plus in front of it, and this will convert it to a number. And still, TypeScript is not happy, because, well, we not always return a tuple. What about this part here? If we make it into the if block, we're showing an alert, but we're not returning a tuple. Well, there are various things we could do instead. We can just return nothing, like this. Alternatively, we could throw an error. Then we would actually not return anything, but we'll throw an error in that case. Now, I don't want to throw an error here because I don't really want to implement error handling. So what I'll do is I'll just add a return statement, but of course this is not a tuple. So actually the return type up here is a tuple, or it's actually undefined. Now, however, as you learned, you shouldn't use undefined here as a return type on functions, instead use void. It's almost the same, but exclusive to functions, and this tells TypeScript that this is a function which has at least a branch which does not return any value, like this one does. Here we also, of course, use a union type because we have both possibilities. We might return nothing, or we actually return a tuple. So now we have gather user input, and user input therefore also is either undefined in the end, or it is that tuple. So now before we move on and improve validation, let's build up on that user input. When we gather the user input down there, we now have that user input thing, and now we can check if it is a tuple. Now the problem is, at runtime, we have no way of checking whether it is a tuple. There is no instance of we could use. There is no tuple type we could check. We can also not check if type of user input is equal to tuple, because that does not exist in vanilla JavaScript. String does exist, for example, but tuple is not a JavaScript type. So to check whether that is a tuple, we have to remember that tuples in the end are just arrays. They're special in TypeScript, but once we're in JavaScript land, they're just arrays, because the idea of a tuple, where the number of elements and the types of elements is fixed, really only exists in TypeScript. So during runtime, all we need to check here is whether it's an array. And for that, we can use the array object in JavaScript, and there the isArray method. That's a method built into vanilla JavaScript, which allows us to check whether this here is an array. We know it's either undefined or a tuple. A tuple is an array, so if this returns true, we got the tuple. And then here, we can use destructuring, for example, to get the title, the description, and the people out of user input, and then do something with that input. For example, for now, console log, title, description, and people. If we do all of that and we save it all, it compiles with no errors. And if we go back here and I click add project like this, I get invalid input. If I enter hello, still get it because we got no description. This is a description. We still get it, of course. But if I now also enter something into people, this works and we print this here. Now that's, of course, a nice step in the right direction. We're not entirely there yet. As I said, we can improve validation. Just one thing I want to do right away before we do that, I want to clear all the inputs after we click add project. So I want to empty all the inputs again. Now for that, we can add a new private method, clear input or clear inputs. And there we can set this title input element, dot value equal to an empty string, and repeat that for the other inputs as well. So here we have the description input element, and here we have the people input element. And now if we call this clear inputs here, we should make sure that the form is cleared once it is submitted. So if we try this again, enter something here, you see it's printed here and the form is cleared. And with that, I'm generally happy with how we handle this, but now I want to improve validation and write this in a more reusable, scalable way. As I mentioned, definitely feel free to do this on your own first. In the next lecture, we'll do it together. So what could we do about validation? Well, maybe let's start at the desired end result. My idea is that we later have some validate function, which doesn't exist yet, but that we later have it, to which I pass the enter title, or actually a configuration object, I'd say, where the value is the enter title, so the thing to be validated, but where I then also have additional properties that tell the validate function how to validate it. So for example, that we have required set to true here, min length set to 5 to enforce 5 characters, and so on. And then we do this here for all 3 inputs, and validate is a function that returns true if it's valid and false if it's not valid. And in the end, we could then have something like this for entered description and entered people. That would roughly be the idea. Of course, it's just one way of implementing this, but it's a way which I like quite a lot. For that, at the top of the file, I will add some validation logic. And again, there are many ways of doing this. I will first of all start by defining the structure of such a validatable object. So of this object we pass to the validate function. Because of course this always needs to have a similar structure with a certain amount of properties which can be there and certain types of properties, so that the validate function actually knows what it's working with and can correctly extract properties and so on. So I will start by defining an interface. We could also go for a custom type, totally up to you. Since I'll define the structure of an object, I'm always a bigger fan of defining just, an interface. I'll name it validatable here because it describes a validatable object, and it will have a value which should be a string or also a number. It will have a required prop which will have a Boolean value, so true or false. And then let's say we support min length validation, which should be a number, max length, which should be a number, and also in case we're getting a number, a min and a max value. The difference to min length and max length is that this checks the length of the string, this the value of the number if it's above a certain number or below a certain maximum. These are the properties I want to support. Now besides the value, they should all be optional though, which we can enforce by adding a question mark after the names. By the way, the alternative to using a question mark is to allow for undefined values. The question mark basically does the same. It says that required is either a Boolean or undefined. So now we have the validatable interface. What can we do with that? Well, now with that interface created, we can create that function, that validate function I'm looking for. That should get such a validatable object. So validatable input is of type validatable. That's my idea here. So it gets an object which has this structure. And now in there, we can check for all these properties to exist and then do the appropriate validation. Now what exactly do we do in the validate function therefore? Well, in the end here, I want to create a variable is valid, which initially is true. So the default assumption is what we get is true, but we'll set it to false as soon as at least one of our checks fails. And now let's start with the first check. Let's see if the validatable input here, this argument we're getting, if that has a required prop, if that's not undefined. If this is set and if it is true, therefore, this means that the value is required and must not be empty. So now in here, we can set isValid equal to isValid and. The way JavaScript works, this ensures that the new value of isValid will be false if the thing after and is false. Because if at least one of the two things is false, the overall value will be false. Now, isValid initially is true, but if the thing after the logical AND operator is false, isValid will be false. And in the end, I will return isValid. So now what do we add after the two ampersand symbols, therefore? Well, I want to check if validatable input value, if that is empty. And for that, we can trim it and check the length. Or can we? Well, the problem is we don't know if value is a string. It's a string or a number. So it's not guaranteed to be a string, and therefore the trim method is not always available. Now, there are various ways of working around that. We could add a type guard. We could check if type of validatable input value equals string and only perform this check if it is. But actually, that would be a bit redundant. What we can do here is very simple. We can simply say, well, convert it to a string. If it was a number, now it's a string again. If it was a string, nothing changed. And with that, we're doing this. Now I just need to add my check here and check if that is 0. Or to be precise, if it's not 0. So if it is not 0, then this will return true and isValid stays true. If it is 0, so if it is of length 0, if it's empty, this will return false and therefore isValid will become false. And we're only checking this if the required check is flagged with setting required to true. That's the first check I want to perform here. It's not the only one, of course. We can continue and check if validatable input min length is set. If min length is set, then this string which we get should have a certain minimum length. Important, the string should have a certain minimum length. We don't care about numbers here. We're not checking for a minimum value of a number. So here we can actually add a type guard. We can incorporate it into this check and check if type of validatable input value is equal to string. If it is not, we don't need to go into this if check because then there is nothing to check. If our value is a number, we don't care about this. If we set a min length for a number, we basically skip this check because it doesn't make much sense. If we do have a string though, and min length is set, then I want to set isValid equal to isValid and then again our check. And the check here is whether validatable input dot value, which we know is a string at this point here, length is greater than validatable input min length, so greater than the value which was defined here. Now we have one potential problem here though, and do you see which one that could be? This should generally work, but it will fail if min length is set to 0. The intention of the developer setting it to 0 is probably not to skip this check, but to check whether we do have a minimum length of 0. Well, arguably it's a redundant check because that's basically checking whether we do have anything at all, which we already do with the required check, so it's not a huge problem. Still, if we want to be super secure here, we should actually check if validatable input min length is not equal to undefined or not equal to null. With one equal sign, this includes null and undefined. That's how JavaScript works. This is a bit safer because now we make sure we always run this check, even if min length is set to 0, which is a falsy value. Again, you could argue if it makes sense because it's basically the same check as up there, but still, here I want to perform it. So that's the min length. Now I'll copy this and basically do the same for max length. So max length here is also checked, also here, and also only for strings. And of course, here we just have to revert this. We want to make sure that the length of the value which is provided is below our max length. Well, and now we got two more checks left for a min and max value, which only makes sense for a number. So here I will add another check and check if validatable input min is not equal to null. Again, I'm not just checking for truthiness because that would have problems with a value of 0. And then I'll check if the type of validatable input value is equal to number, because I see not much sense in checking this for a string. If you want to check it for a string, of course, you can omit this. Then you just have to make sure you convert the value to a number when you use it in the check we're about to write. The check we're about to write again uses the old value of isValid and combines it with a new check to then store it back in isValid. And the new check should now, well, incorporate our number and check whether it's bigger than the min value. So here I check if validatable input value is greater than validatable input.min. And now we can repeat this for max. So here we need max, and here we also need max, and we need to change this here to a smaller than symbol. With that, we're checking all the different scenarios we could have here, and we're returning is valid. Now we just need to create objects that adhere to this interface to then send them to the validate function. For that, let's go down to project input, and there in gather user input, I want to construct my validatable objects. Side note, besides an interface, of course, we could have also created a class here, then we could instantiate it with the new keyword, but also for practice and demo purposes here, I want to show how this works with an interface. So here we have our title validatable, which should be of type validatable. And that, of course, is an object which needs to have a value property, and that's our entered title. It doesn't need any other properties, but I want to check whether it's, well, not empty, so we'll set required to true. And then we can copy that and repeat that for the description and for people. And here we have the description. Whoops, the entered description, I mean. Here we have the entered people. To be precise, here I want to have a number, so I convert this to a number with a plus symbol. All should be required, but then also here, let's say the description should have a min length of 5 characters. And for the people, the minimum should be 1, so that we have at least 2 people assigned. By the way, it's up to you how you implement this. Of course, in your validation logic, you could also check for greater equal, smaller equal if you like to. Same for the length, of course. Greater equal, smaller equal. That's also possible. Actually, I will keep these changes. So now we have a minimum of 1 person assigned and a max of 5. Now we have these 3 validatable objects, and now here to the validate function, we pass our title validatable. To the second function call, I pass the description validatable, and to the third function call, I pass people validatable. And now validate should return true if they're all valid and false otherwise. So now I want to check if at least one of them fails by checking if these are all false by adding an exclamation mark in front of it to check if this is false, or this is false, or this is false. And if at least one of them is false, so if at least one of the validate function calls returns false, we'll make it in there and show the alert. Well, and with that out of the way, to also test this, I'll go to index.html, because there on the input for people, I actually allow a maximum of 10 and a minimum of 0. So in the input, we technically can enter invalid values, on purpose, of course, so that we can test our logic. And therefore now, let's save it all. Compiles without errors. Let's now give it a try. If I click Add Project, I get an error, which is good. Now let's enter test here. Still get an error. Let's enter test here and 5 here, and I still get an error because my description is too short. If I enter one more character, I do have the min length, and I can create this. So now let's enter, let's say, -1 people. And, well, okay, HTML doesn't support this, but let's enter 0 or 6, and we get errors. And only if I enter something between 1 and 5, it works. So that seems to work as it should. And that's pretty good. And that's, of course, just one way of implementing validation, but a way which actually is now quite reusable, could be used like this in different parts of the app as well. And of course, it takes advantage of TypeScript and offers us great support and type checking to avoid unnecessary mistakes. So now that we're able to fetch the user input and also validate it with the help of our TypeScript-driven validation logic here, let's move on and let's make sure we do more with that gathered user input than just output it in the console. Because at the moment, this of course is what we're doing, right? In the end, I'm just printing the things, the information we gathered to the console, and that's not our final goal in this application. Instead, the goal should be that we also render this list of projects here based on this template, where every project item is based on this template here, and we output the information we gathered here. So that will be the next thing I want to work on. Besides having our project input class here, which is responsible for rendering the form and gathering the user input, I want to have another class which is responsible for rendering a list of projects. And actually, I will split that into two classes, one class for the list and one class per project item in the list. And then we need to find some way of passing that gathered input here basically to our project list and add a new item to it. So let's tackle this step by step, I'd say, and let's start by adding a project list class. Now, the exact place where you add it is up to you. The order does not matter because JavaScript in the end will parse this entire file entirely before it executes it, so it will be aware of all classes. Still, I will add it here above the project input class because I kind of rely on the project list class, which I'm about to build inside of the project input class. But again, it doesn't really matter. So here I'll have my project list class, project list. And the idea of this class here is a bit related to what we did in project input. I want to reach out to my template here and then render it in a certain place of the application. And therefore, what we can do here is we can again add a constructor. We can add the fields we need, and there we'll need the template element and the host element in the end. So we can add both here to our project list. We'll also need the element itself, I'd say. So the concrete element which is getting rendered. And the types will differ though. The host element will still be a div because I want to render that list in that div here as well. But the concrete element which we do render, of course, is not a form element. But if we have a look at our list template here, we see there's a section inside of it. So we have a section element. Now, turns out there is no element, no section element, so we'll just have a regular HTML element because every element has this type here. For some tags, there are more specialized types. If they aren't, we can just use HTML type. So now, of course, we need to get access to these elements. So we can copy this code here, actually, from the constructor of the project input, add it to the constructor of project list, and now adjust some things. For example, my template element, of course, now doesn't have an ID of project input. That's now project list instead. So let's copy that and use this here to select the element. I will still cast it, and I still know with certainty that I get it, so this doesn't change. The host element still is the div with the ID app, so this does not change. Then I import my content, and then I, store the first element of the imported template. So basically the first element in the template, which is the section. I store that in the element property here. However, this is not an HTML form element. It's just an HTML element here. Now we also can assign an ID here, and actually the ID should be dynamic, not hard-coded, because we'll have more than one list of projects. I want to have two lists in the final app, one for the active projects and one for the inactive projects. And therefore, I want to get some additional information in the constructor, the type of the project, and I'll use that TypeScript shortcut you learned about, where you can add an accessor in front of the parameter, private or public, to automatically create a property of the same name and store the value that's passed in on this argument in that equally named property. So now this class will have a property named type as well. And now the question is, what's the type of this type parameter? And this should actually be a literal type and a union type. It's either active or finished. We either have active projects or finished projects. So that's an argument I expect to get when the project list is instantiated. And with that, we have this type property. The ID should then be based on this. It should be, and for that I use a template literal here, it should be type-projects. So either active-projects or finished-projects. That's my idea here. You can also use this.type so that TypeScript understands that we're using this property and that it's not unused. So with that, we're getting access to all the core elements and we're adding an ID to the section which we get out of our template. Now, of course, we wanna render it, right? That's the idea. For this, I'll again add a private method, attach, just as we had it in the project input. And in there, it's now the goal to, well, attach this to the DOM, to now render that list to the DOM. So inside of attach, I will actually do the same as I did in attach for the project form. So we can copy that line here and add it to attach. I have my host element and I want to insert an adjacent element after the beginning, and this should be the element we extracted from the template. Here, however, I actually don't want to do that after the beginning, but instead before end, which means before the closing tag of the host element. And then we can call attach here in the constructor, of course, to attach our created element here to the DOM. Now there is one important difference compared to the project input though. For this list, it's not done with just adding the list to the DOM. The input was finished, right? The form here was finished. We had all the inputs there. All we needed to do was set up an event listener. Now, for the list here, we actually have a header with an empty h2 tag, for example, and I want to add some text there. So I will add another new method here, a private method. Render content could be a fitting name. And my idea here is to fill the blank spaces in that template with some life here. For that, let's go to that render content method. And there are a couple of things I want to do. One thing is that for that unordered list, which is part of my project list here, I want to add an ID to it. Of course, you don't have to do that, but I want to do that so that if we need to select it later, we can do that with these. So I'll create a list ID here, store it in a constant, and this will be a template literal, so it will be a string where we can inject dynamic content. And I want to base this on the type of the surrounding project list, so of the surrounding section, and then add projects list thereafter. Now we can reach out to the unordered list, which we get in our element, which is that section here, right? Element is that section. So to get the unordered list inside of there, we can, for example, use a query selector and search for the first, and in this case, only unordered list. We know we will get one because we know there will be one, and then we can add an ID here, which should be the list ID. That's one thing which I want to do. I also want to set the text content of that h2 tag here, and for this, we can reach out to this element query selector, find the first and only h2 tag. We know we will find one, hence the exclamation mark to rule out that null case, and set the text content equal to this.type to uppercase. Remember, this.type is either active or finished. With to uppercase, we convert this to all caps, plus projects. So this is then simply the heading for this section. And now with that, we're generally done. We have no items in that list yet. We'll work on this later, but we're generally done. We can call this render content after we attached it to the DOM, for example. Now it would be nice to see that in action. Of course, again, list items and so on will be missing, but it would be nice to see something in action here. Well, for that, let's go to the bottom of the file where we instantiate the project input. And there we can now also instantiate our lists. we have the active project list, which we instantiate by calling new project list. And there we have to pass in that type argument, which is either active or finished. Here, since I'm rendering the active list, I of course pass in active. And then here we have the finished project list, where I of course pass in finished. If we now save that, it should compile without errors. And hence, what you should see if you go back are these two empty sections here, with the headings here and, well, the empty space where later items will be added, project items will be added. Now, for the moment, we have no such project items though. So, as a next step, we should work on some way of making sure that when we click Add Project, that we create a new project in code, so a new data structure which represents a project, and that we then pass this information about this new project to the active projects list here, to this active projects section, because every new project should be active by default. This will be our next goal, and again, there will be many different ways of implementing this. We'll do it together with one way I came up with in the next lecture. So getting projects from A to B is now our goal. To be precise, when users create a new project, when they enter all the data, we want to create a new project object in the end, which we then output in our project list class as part of the unordered list which is rendered there. That's the idea. Now, of course, a trivial way of implementing this could be to simply go to the place where the user input is entered, and then here use document get element by ID to reach out for that unordered list we rendered as part of our project list class, which has this ID here, so active-projects list or finished-projects list, and then simply reach out to that and add a new item to it. But that's not really the idea of how I want to build this application. I want to build it in an object-oriented way where we have our different classes that work together in a reactive way, where we create a new class and then something happens in the DOM, where we call a method of a class and then this class does something. That's how I want these things to work. Now, of course, we could add a method to the project list class. Let's say a add project method. That method should then be called when a project should be added and rendered, and we would have to find some way of calling it from inside the project input. To do that, we could make sure that we actually pass references to our lists here to the project input constructor, so that from inside the project input class, we can work with these concrete instances and call the methods on these instances, because that is what we would have to do. That would be a viable way, definitely an approach you could take, but I want to take an even more abstract approach, even more interesting approach in my opinion. I will build a class which manages the state of our application, so to say. A class which manages our projects or whichever state we might need to manage in the application, which also allows us to then set up listeners in the different parts of the app that are interested. This is a pattern that might sound familiar to you if you worked with frameworks like Angular or libraries like React and Redux, that you have a global state management object and you just listen to changes. That is what I want to implement here. Of course, it's just one way of doing this, but I think it's a quite interesting way, which is why I want to show it. So at the top of the app.ts file, I'll add a project state management class, and I will simply name it project state. Sounds like a sensible name to me. Now, the idea here is that in this class, we have a property or a field, a private field, projects, which holds an array of projects. Now, we also need to define how a project should look like. We'll do that in the next step. For now, I'll just say it's an array of anything, which of course is not perfect, not final, but I want to focus on that state management solution for now. So we have this list of projects here. Now my goal is that I want to add an item to that list whenever we, well, click that Add Project button here. To make that work, inside of the project state class, I'll add an add project method, a public one, and there I expect to get the title, which should be a string, the description, which should be a string, and also the number of people working on the project, which should be a number. Then in here, we can create a new project with the object literal notation for now, where we should have some ID for every project so that we can uniquely identify it. And I'll generate an ID here by using moth random toString. Now, a random number is not really a unique ID. You can generate the same number more than once, but it's very unlikely, and for our demo purposes here, it will do. Now, besides that, every project should have a title, and there I will store that title argument we're getting. Same for description, where I will store a description, and my people, where I will store the number of people. This, for now, is the project I want to store. So once we created it here, we can reach out to the project's array in the project state, which is private, but from inside the class, which this method is, we can access it, of course. And there I want to add this new project, and for that we can simply push our new project to it. Now with that, we are able to add a project. But we still, of course, have a couple of unclear questions. How do we call add project from inside our class down there where we gather the user input from inside the submit handler? How do we call add project? And how do we pass that updated list of projects whenever it changes to the project list class? These are the two issues we, of course, face at the moment. Well, one thing I will do here is I will create an instance of project state here, a global instance which we can use from the entire file, and I'll do it right after we create that class. So here I have my project state constant where I instantiate project state like this. This way, this is a global constant that can be used anywhere in the file, so talking to that class is now super simple. You just have to use this global constant here. We can even use a feature we also learned about, the private constructor, to guarantee that this is a singleton class. We can create a private constructor here, and then we have another private property here, instance, which is of type project state, so of the same type this class is of. And we then add a getInstance method here, a static method actually, where we check if this .instance is a thing, and for that, this actually also has to be a static instance, a static property, I mean. If this is a thing, if it is, we return this .instance, so we return our singleton instance we got. Otherwise, we create a new one. So otherwise, this .instance will be equal to new project state. And then we return this .instance. Now with that, we can call getInstance down there, like this, project state getInstance, and we're guaranteed to always work with the exact same object, and we'll always only have one object of the type in the entire application, which is the idea here, because I only want to have one state management object for our project, and that is this project state with this singleton constructor now. So now we have our project state constant. Let's go down to the project input class, therefore, where we gather the user input. Here, we can now call project state add project and forward the title, the description, and the people we get back from gather user input in the end. So now this project should get created. Now we just need to push that information that we have a new project to our project list class, because that's the class which is responsible for outputting something to the screen. And for that, I want to set up a subscription pattern in the end, where inside of our project state, we manage a list of listeners, so a list of functions in the end, which should be called whenever something changes. So for that, I'll add another private property here, listeners, and listeners will be an empty array. And for now, again, just an array of anything. We will specify this in greater detail later. Now I also want to have a method here, add listener, where I get a listener function. So this should be a function in the end here. And I will then add this to my listeners. So we push the listener function here to, well, the listeners array. Now, what's the idea of having that listeners array? It's an array of functions, of function references, right? The idea is that whenever something changes, like here, when we add a new project, we call all listener functions. So we loop through all listeners of this listener, so through all listener functions. And then, since these are function references, we can execute this as a function. And to that function, we pass the thing that's relevant for it based on the state we're managing, which in this case of this class, of course, is our projects list. This is the state this class is responsible for. So here, I forward this project, and I will call slice on it to only return a copy of that array and not the original array, so that it can't be edited from the place where the listener function is coming from. Because arrays and objects are reference values in JavaScript, so if we would pass the original array, we could edit it from outside, and also on the same hand, if we push something to it from inside this class, it would already change everywhere else in the app, but these places would not really notice that it changed. So we could introduce strange bugs if we pass around the original reference, which is why I pass around a brand new copy, a brand new array here. So now every listener function is getting executed and gets our copy, our brand new copy of projects. Now we just need to go to the places where we want to be informed about changes, in our case the project list class here, and set up such a listener. So here, in the constructor of the project list class, before we attach and render the content, I will reach out to project state and call add listener here to basically register a listener function here. Now a listener, as I said, is a function, so we have to pass a function to add listener, because the listeners we're managing here in the project state, that's just a list of functions which we will eventually call when something changes, right? So I will need to pass a function to my add listener function here. Here I'm passing an anonymous arrow function, and that function will get a list of projects when it is called from inside project state. So we get a list of projects, we know that. Inside of this function body, we can then use this list of projects. And here I will add a brand new field to the project list, assigned projects maybe, which is of type any array, so anything in an array of any values. We'll of course also specify this in greater detail later. And then here we can say this assigned project is equal to projects, so to the projects we're getting. Now here, to get rid of that implicit any type error, I have to be clear that this will actually be an array of anything here. So now I'm adding the projects, which I get because something changed in my state, here to my assigned projects. Or I'm not adding it, I'm overriding the assigned projects with the new projects. And then my idea is to render all these projects. For that, we can add a new method, render projects, for example, which I want to call from in here, this render projects, just like this. And inside of render projects, I'll reach out to this list here, right? We assign that ID when we render the content, which we do here. It looks like we do this after render project is called, but keep in mind that's inside of a function which will only eventually be called once new projects are added. So actually render content will run first. And therefore in render projects, we can rely on this ID being assigned to an unordered list. So here we can grab this and get our list element by using document get element by ID, and then I just pass in this ID identifier using the type of this concrete project list class, and then also using the rest of this ID we generated. And to that list, or in that list, I want to render all the projects we have. So I will go through all the project items of this assigned projects here, And then for every item, I want to add something to the list. And we'll refine this later. For the moment, I will just call append child here on my list element. By the way, here we should add an exclamation mark to make it clear that this will not be null. We can also cast this to an HTML UL list element, to an unordered list element, because that is what it will be. And then we can append a child here, and that should be a brand new list item. So here we can create our list item with document create element li. And on that list item here, I just will set the text content equal to project item.title. Every project item will be a project as we create it up there in the project state. So it will be such an object, and therefore it will have a title. Now with that, if we go down there, we have our list item, which now is added here. And with that, we're almost there. Remaining fixes here. I set up that field, but in the constructor, I then never reference it, only here in my listener function. But as mentioned, this does not run immediately in the constructor. So what I'll do here is I will set this assigned projects equal to an empty array here initially, so that we're all happy and this is initialized. Now if we save this, it should compile without errors. And now if we add something here, does this work? We indeed see it show up in our lists. In both lists at the moment, because we have no filtering logic and so on. And that is something we can fix later, but it does work. And that's the important thing. Now you see we also have a bug here, however. If I add a second element, we duplicate the last element and add the new element. So that's something we'll have to fix. And these are all things we will tackle. But now at least we're able to output something. With that, let's dive into all the improvements, like being clearer about the types we're using, avoiding the duplicate output, and many other things as well. As a next step, I want to work on these types here. The any type I'm using here for my assigned projects, for the listeners here, and also for the projects in the project state. Of course, here I don't really want to work with any. It would make more sense to have a dedicated project class or project type which we can use. And indeed, I will create a class for that, project type, simply by using class project, so that we have a way of building project objects which always have the same structure. Right now I'm doing it down there with the literal notation. The downside of that, of course, is that we have to remember that it's description and not desk, that we need an ID, which is a string, and so on. So that's where a custom type can help us, and I'll create a class and not an interface or a custom type with the type keyword, because I want to be able to instantiate it. So how should such a class look like, or how such a project look like, to be precise? Well, I'll add a constructor and then use this shortcut of assigning arguments or parameters to the constructor, which then automatically become properties as well, by adding the accessor at the beginning, public in this case, and then the name of the argument and property, and then the type. And here, every project should have an ID. Every project should have a title, which also is a string, just like the ID. It should have a description, which is a string. It should have a people property, which is a number. That's the number of people assigned to a project. And one thing I also want to add, which we didn't have thus far, is actually a project status. Because right now, when we add a project here, it appears in both lists. Now, I want to add a status to a project, which of course can be changed, so that we actually can filter for active projects in the first box and finished projects in the second box, so that we only show the right projects in every box. So for that, I'll add another public property here, status. And now the question, of course, is which type should this status have? Now, we could use a union type with two literal types, active and finished, what we used earlier already. But here, I also want to introduce or reintroduce another type we learned about, and that's the enum. The enum is perfect here because we have exactly two options, and here in the context of this project object, we also don't need a text which makes sense to humans, which we store as a value, but we really just need some identifier. So here I'll add a new enum, project status, and I want to have two values there, active and finished. And then here, this status will be of type project status, just like that. This is now my project class. With that here, we can say that this is an array of projects using that project class. And of course, when we create a project here, we do that by using new project, project, not project state. And here to project, we forward an ID, in this case, as mentioned before, a random number, which we convert to a string, then the title, then the description, then the num of people here, and then also, of course, that status, right? And one thing I want to have here in this application, in this demo project, is that every new project by default is active. So when we create a new project here, we assign project status.active here as a value for the status. With that, we have the project which we add. And now there's one other place where we need the project class, and that is here in the project list class. There we have the assign projects property, and of course that should also be an array of projects. Now with that, we're using better typing, and one advantage is that here in render projects, we now also get auto-completion here, for example, and we would also get an error, a compilation error if we try to save that, because now TypeScript understands with which types we're working here. So that's the project class and how we can use that. The project class isn't the only class, however, we also have the listener here. And for that, I'll add a new custom type, listener. The name is of course up to you. And I just use a type here because I want to basically encode a function type with one word. So what do I mean with that? Well, of course, a listener here in our application is just a function, right? What we store in the listeners array is just a bunch of functions. Add listener pushes a new function, and when something changes, we execute that function. So here a listener is really just a function, but it is a function that receives our items, certain items, in our case, an array of projects, and that then does something with it. Now, to be precise, here, of course, to define a function type, we don't have curly braces here, but instead, as you learned, the return type, and that will be void, which means we don't care about any value that listener function might return. In the place where we work with listeners, we don't need any return type. We just want to ensure that whoever passes us such a listener expects to get some items when the listener fires. With that here, we can say that listeners is an array of listener, well, functions in the end. And here, when I push listener function, I need to make clear that it's not just any function, but that it's of type listener. Then everything works. Now in the place where we use add listener, which is down there, we now also, of course, can enhance our typing and make it clear that here we will actually get a bunch of projects. So now with that, we set up our listener, we added the project type, and that changes nothing here. If we now add something, that works, and if I add a second item, that still gets added besides the first item being added again as well. And we're not doing any filtering in any of the lists at all. So before we continue working on other parts, let's make sure we're not having this duplication here inside of a single list, and also not the duplication across both boxes here, but that instead only active projects are showing up here, and only finished projects, and therefore initially no projects, show up here in finished projects. So let's fix that. So we got two issues, if we want to call them like that, to fix. Now I want to start with the issue that projects show up in both boxes. I want to introduce some filtering. And the best place to filter is, of course, our listener function. If we go to the place where we register our listener, here in the project list class. Then here we get a list of projects, right? Now, that list of projects comprises all projects. Now, inside of the project list class, however, we're only interested in active or finished projects. Now, here, by the way, we could also theoretically use our enum, but actually, I need the concrete value stored in the enum down there, or in the type down there, and therefore here I don't want to use a enum, also because I want to show the string literal types. So what we'll do here inside of our listener function is, before we store the projects and render them, we want to filter them. So here we have our relevant projects, you could say, and that's of course projects filtered. The filter method is a default method which exists on any array in JavaScript. This takes a function which then executes on every item in that projects array, and when this function here returns true, we keep the item in a newly created array, which is then stored in relevant projects. If this function returns false, we drop the item, not from the original list, but in the new list which is generated and which is stored in relevant projects. So in here we have to return true or false depending on whether we want to keep the project or not. And for that, of course, we just need to look at the status. Project status is an enum, and we want to check whether project status is equal to project status active if we're in an active project list, so if the type property is active, or if the project status is finished if we're in a finished list. So here I'll actually write a real function body by wrapping this with curly braces, not using the arrow function shortcut, and then we can check if this type is equal active, then I want to return the result of this check here, else, and therefore simply after this if statement, I want to return the comparison to the finished project status. With that, we get our relevant projects, which we can now store here in assigned projects. So let's now see whether that works. If I reload and we add a project here, does this work? This works, and you see it only is added to active projects, not to finished projects. However, if I add a second project here, we still have that duplication going on. Now that's related to how we render our projects. Inside of render projects, we always go through all our project items and append them to the list. Now the problem with that, of course, is that we already might have a project item rendered out onto the screen. Now, the best possible solution here would be to kind of run some comparison where you check what has already been rendered and what you need to render to avoid unnecessary re-rendering. However, running this comparison by looking at the real DOM also costs quite a bit of performance. For this application here, it's therefore perfectly fine to simply take our list element and clear all its content by setting inner HTML to an empty string, which means we get rid of all list items and then re-render. That means that whenever we add a new project, we re-render all projects, but for the purpose of this project here, for this application here, that is absolutely fine. So now with that, if we save that, let's give it another try. Does this work? Is the first project. And now if I add another project here, you see it gets added, but the other project doesn't get added again. Whoops, and now here I got a validation error because the description wasn't long enough. So this now all works, as you can tell, and we're rendering these projects in the way they should be rendered, which of course is great. And with that, the application doesn't look too bad. Now, one thing that's missing is some drag and drop functionality or some way of getting projects from this first list to the second list. We're also not really outputting the other information we got, description and number of people, so that's also not great. And we also have a bit of code duplication when we actually have a look at project list, at this class here, and at the project input class. In both, we have template element, host element, and we have an attach method, and so on. So I want to improve the code here and reuse some code by using inheritance and using a base class. And thereafter, I also want to create a dedicated class for every project item, where we then just instantiate that project item class inside of project list instead of appending a list item manually like this. And then inside of that to be created project item class, that appending part should happen. And then I also want to output more information about the project item, including its description and the number of people assigned. So there is some work left to do, and before we work on the project item in that form in which I want to have it, let's actually make sure we first of all add some inheritance to make our project list and project input, or certain parts of it, more reusable. So time for some inheritance and for a base class. I want to add a base class which basically has template element, host element, and element in it, which does this job of selecting elements in the DOM, which has the attach method, which we always need, and so on. So which basically manages all these shared functionalities which our classes that actually render something to the DOM have in common. So for that, above my project input and also the project list class, so basically here, I'll add the component base class. Now, the name is up to you, but I'll name it component because you might know this term from React or Angular if you work with that. And even if you didn't work with that, you can think of these classes as UI, user interface, components, which we render to the screen. And every component is in the end a renderable object which has some functionalities that allow us to render it. And then the concrete instances, or the inherited classes, add extra functionality which this specific component needs. So what goes into the general component class then? Well, I would say these three elements for sure: template element, host element, and element. Now we do have a problem here, however, regarding the types. The template element will always be a HTML template element, but the host element doesn't always have to be a div. For example, when we will add a project item class, we'll render that in a project list and not directly in our root div here. So that's not always a div. And this here, well, it's always an HTML element. We can certainly settle on that. But like in the case of the project input class, we actually know that it's a more specific form of it. It's a HTML form element. So we would lose this extra information if we restrict ourselves to always having just an HTML element there without storing more specific information. So how can we work around that? Well, by not just using inheritance, but by creating a generic class here, where when we inherit from it, we can set the concrete types. For that, we add angle brackets after the class name, and then two identifiers of our choice, like T and U, which would be common choices. And now we also can add some constraints here and say that T will certainly be some kind of HTML element. It can be just an HTML element or a more specific version of it. And the same is true for U. And then here we know the host element will be of type T and the element will be of type U. And now whenever we inherit from this class, we can specify the concrete types so that we can work with different types in different places where we inherit. Now let's also add a constructor here. In that constructor, we will need a little bit of information. We need to know the ID of our templates so that we know how to select it, and that should be a string. We need to know the host element ID, which also needs to be a string, so that we know where to render this component. And I also want to get a new element ID so that we get an ID that has to be assigned to the newly rendered element. This, however, is optional, which I signal by adding a question mark after the parameter. The alternative would be to also accept undefined here as a type, but I'll just use the question mark. And now with that in the constructor, we can basically get this code here and put it into our constructor of the component class, so that we store the template element, but of course now the ID which we're getting here is that template ID, which is why I'm getting this as an argument in the constructor. And for the host element, the ID here of course is our host element ID, like this. Also important of course, regarding the casting here, we know this will be of type T. because T here is this generic type which we store or which we use for our host element, so here we can cast it already. And with that, we're selecting elements. We can also grab more code. That code here, where we import a node and so on, and where we set the ID, we can grab all of that. So let's copy that here and add this to the constructor of the component class as well. Imported node, then we set element, and element here has this generic type U. So when we cast this here, we know it will be that U type here, so we should cast it to U. That's a good use of generics here, which makes this component class really reusable. Now regarding the ID, this is what we get here, the new element ID. Now of course, we might not always have this because it's optional, so we should check if we do have it. So if new element ID is a thing, and only if it is a thing, only then I will try to assign it. Otherwise we don't try it because then we have no ID to assign. Well, with that we have the constructor. Now let's use the attach function here. So let's copy the attach method from one of our other classes and add it here as a private method in the component class. We can then also call this attach at the end of the constructor of the component class. Now here we want to add an element, but we don't know where it should be added. So that's actually some extra information we should fetch here as a fourth argument in the constructor. Insert at start could be a name, and that is a boolean, let's say. And we should move that in front of our optional parameter. Optional parameters should always be last because people might omit them. Your required parameters therefore can't come after these optional parameters. And insert at start is then forwarded to attach. There, insert at beginning, you could also reuse insert at start, I'm just using a different name here to avoid confusion, is received as a boolean. And then here we check if insert at beginning is true. If it is, then here we have after begin, otherwise we have before end. Now we're flexible regarding how this gets inserted. I also want to mark this class now as an abstract class because people should never directly instantiate it. Instead, it should always be used for inheritance. So in front of class, I add the abstract keyword. This makes sure that now we can't instantiate it. If we would try to do so, TypeScript would yell at us. I will also add two more methods, and that's the configure method and also then the render content method. And I will add it as an abstract method, which means the concrete implementation is missing here. But we now basically force any class inheriting from component to add these two methods and to have them available. I'm just adding this here so that if someone else looks at our code, he or she can get a good understanding of what the idea behind the component class is. That it does all the general rendering or the attachment of the component, but that the concrete content and configuration then needs to happen in the place where we inherit. Side note, you can't have private abstract methods. So private has to be omitted here. That's not allowed by TypeScript. Well, and with this, we can extend component here on the project list and now get rid of these three properties. We keep the assigned projects because that's specific to the project list. We also now want to specify the concrete values that should be plugged in for our generic types. And we know, if we revert this, we know that we'll have a HTML div element and a HTML element. So here I will pass in HTML div element and HTML element like this, and then get rid of these three properties. In the constructor, we now don't need that here, but instead we need to call super at the beginning to call the constructor of the base class. And to that, we need to pass some information. To the super constructor, we need to pass some information. The ID of our template element, the host element ID, whether we want to insert this at the start of the host element, and potentially the ID that should be assigned to the new element. So here's our template ID. With that, we can get rid of this here. Then here, the host element, that ID was app, so we can get rid of this. We keep the assigned projects because we still need that here. We get rid of this here. But regarding the ID for the new element, I want to pass that as a fourth parameter actually. The third one is where this should be inserted. And here we used to insert this before the end. So actually what I want to insert here as a parameter for the insert at start value is false, because it should not be inserted at the start, but at the end. Now, I certainly still want to set up my listener here. I don't need to call attached though. That will happen in the base class, in the base component. I will call render content though. And here we shouldn't use this type, but just type, because we can't use this before super finished running. That's no problem though, because we receive type as an argument. Now you see I still get an error here, because we have an attach method here in project list, and that clashes with the attach method we have in the base class. So let's get rid of this attach method here. Now we still get an error, because you see render content is private here, but we specify it as a public method here. I would love to have it as a private one, but private abstract methods are not supported. So I will remove the private keyword here. And now with that, we're left with one issue here, that we're not having that configure method, which I promised to have here. Well, let's add it. So here, besides render config, we can add configure, even though I'm not doing anything here. Alternatively, you could convert this here to be an optional method by adding a question mark. Then you're not forced to add it. Here, I will add it, because we could also argue that we, for the project list, put that code where we set up our listener here actually into configure. So we can reach out to configure and then do our thing here, that listener setup. And now we should just make sure that we call render content, but also configure like this. In case you're wondering why I'm not calling configure and render content here in the abstract class in the constructor, well, we could do this, but we might have a problem then. If we call this in the component class, then we might call a method in the inheriting class, so in a class that extends component, where render content or configure relies on something where the constructor of the inheriting class actually maybe sets something up only after the base class constructor finished, which render content and or configure rely on. That's why it's safer to basically make sure that the inheriting class has to call these methods instead of the base class calling these methods for us. So with that, we restructured the project list class to take advantage of inheritance and of our shared logic. Let's do the same for project input now. There, we also want to extend component, use the generic nature of that, and there we have the HTML div element for the host element and the HTML form element for the element which gets rendered. With that, we can get rid of these three properties here, so let's do that. We keep these three properties, of course, because they're specific to project input. We then have to call super here, and to super, we pass the ID of the template, which is project input, the ID of the host element, which is app. Insert before here is true, because I want to insert that newly created element at the beginning here for this project input class. And then a new element ID. Well, that here is user input, so we should also forward that. With this, we can get rid of this code, and of all this code here, actually. Of course, keep this code here. However, we could also argue that we put this into configure, maybe. So let's go down to the configure method, which we already have here, and add our listeners here, or our property setup here to configure. Of course, let's get rid of attach, because that's now something the base class does for us. And let's check what TypeScript doesn't like. Of course, we should get rid of the attach here. And yeah, actually, one thing TypeScript doesn't like, it now complains that these fields do not get initialized in the constructor because it doesn't understand or doesn't check that configure is called in the constructor and does this initialization. So to satisfy TypeScript, I'll actually move these initializations back from configure right into the constructor. Technically, the result is exactly the same, but now TypeScript won't complain. It will complain, however, that we do have a private configure method. So just as before, we should change this and turn configure into a public method. Now, it's not a must do, but it's kind of convention to have your public methods first, which is why I will move it up above the other private methods here. And of course, now it also complains that we have no render content method. Now, I will add one just because we need to. Here, we're not doing anything in it, so technically it's not required, but now we satisfy our base class. Side note, render content and configure in the project list class can also be moved above that private method here for the exact same reasons for this convention I just mentioned. And with that, we also restructured project input to take advantage of inheritance and let the base class do a lot of the job. Let's see whether that now all works. If we save that, it compiles without errors. It seems to run fine. So does this work is the question. And that looks quite good. It works the same way as before, but now we have cleaner code where we take advantage of code reusage thanks to inheritance. Now, it's not the only place where we can inherit. I want to conclude this lecture here by also refactoring our project state. Technically there we don't need inheritance because we only have this one single state we manage in this entire application. But imagine a bigger application where you have multiple different states. One for the user state, whether the user is logged in and so on, one for the projects, one for a shopping cart. Now you will notice that some features of your state class are always the same, specifically that array of listeners and the addListener method. So we could also use a base class here. We could use a class state here, and that class has a listeners array, and that class also has an addListeners method. So we'll cut both from project state and add it to state. Now that also means that we of course don't know whether our listener will actually return an array of projects. So actually here, for this function type, I also want to have a generic type actually, so that we can set this from outside. We can do that. We can write a generic type like this here, a custom type, which is generic. We can add the angle brackets after our type name, use an identifier of our choice, and then reuse that type here. Now we can make state generic. We can use the same identifier because it's a different construct than our custom type. And then here, when we say that we want to have a list of listeners, we have to tell TypeScript which generic type the listeners use for this state object we're creating. And that simply means we can forward our generic type here and here. So when we now extend state, we have to specify the type of data this state will work with. And inside of state, this then gets forwarded to our listener custom type. That's the idea. Now, how do we use all of that? Well, down there in the project state class, we simply extend the state class and now provide a value, a concrete value for that generic placeholder. And here, this concrete value is project, because this project state is all about managing, guess what? Projects. Now, the private constructor here has a problem, as you can tell, because we're not calling super. Well, we should definitely do that. Let's call super in here. That's all we gotta do there. And here, if we scroll down where we go through the listeners, we see listeners is private, and it's private in our base class. Now that means we can only access it from inside the base class. But you learned about another access modifier, which is similar to private, but also allows access from inheriting classes. And that would be protected. Protected means it still can't be accessed from outside the class, but it can be accessed from any class that inherits. With that, let's save all of that. It should compile just fine. And let's quickly test this. And that's looking good. So that works as before, but now again with a bit nicer code using inheritance and generics also for our state management. With all our inheritance work out of the way, let's come back to rendering list items. Let's render more details there. And as I mentioned, let's also make sure we render them differently. Thus far, we followed an object-oriented approach. And for example, for our project list, we have a class, and when we instantiate that class, such a box gets rendered here. And the same for the input. We have a project input class, and when we instantiate that, this project input area here at the top gets rendered. Now, why don't we do the same for a project item, and then inside of project list in render projects, instead of creating a list item like this, we would just instantiate our project item class, and in the constructor of that project item class, we would then do all the initialization and so on. That is my idea, at least. Now, as always, you can pause the video here and try this on your own first, but after a short break, which I give you to pause the video if you want to, we'll do it together. So, let's do that together. And for that, above the project list class, I will add the project item class. And this will be the class responsible for rendering a single project item. Now, the project item class should also extend the component, because it will be a class that is responsible for rendering something on the screen, and that is what we have our component class for, right? That is what we built it for, so that we pass a template, a host element, and so on. So in project item, we of course need a constructor where we then also have to call super. And actually, before we call super, let's set these generic types for the base class we're inheriting. Keep in mind, the first type we pass in there is the host element, so where we want to render something. The second generic type we pass in is the element we do render. So in the case of the project item, that means that the first element we pass in is, since it's the place where we want to render something, is an HTML list, an unordered list, because every project item will be rendered inside of a, unordered list. And the second element will be a HTML li element, so the concrete list item element which will be created. Now, to super, we need to provide the ID of the element where the project item should be rendered in. And of course, that ID is not fixed, because we have two lists where the item could be rendered to. So I expect to get that ID here in the constructor. There I want to get the host ID, let's say, which should be a string, and we can forward that to super. However, the first thing we forward to super is the template ID for a single list item, and that is this template here. So we can just grab that. Now, of course, that's a very simple template. You could argue whether you really need that. It's just a list item. We could create that in code with document create element as well. But in order to be able to reuse our component base class, which relies on templates, we will use this approach. So single project is the template ID. Host ID then is the ID I want to forward to the base class constructor. Then, to answer the question whether this should be rendered at the beginning or at the end, well, every new list item should actually be added to the end of the list, though that is totally up to you. You can also add it to the beginning if you want to. But here I'll go with the end, and therefore I will pass false here. And then for the new element ID, so the ID that should be assigned to the newly created element, I expect to get that from outside as well, because that will also differ for every project item. We will render multiple such items after all. So here I expect to get the ID, which should also be a string, which I then just forward. So that's now the constructor. Now, it would also make sense to store the project that belongs to this project item in this project item class. And with project, I mean the project based on our project class, which we created up there. This is basically what we work with, the data we work with. And I want to store the project which belongs to this rendered project item in that project item class. So therefore here we can add a private property, project for example, which should be of type project like this. In the constructor, we then do get the ID, and we can simply change this to actually get the project here, like this, and then simply say this project equal project, and here, since every project has an ID property, we just forward project.id. I think that setup makes a bit more sense. Now we also need to add a couple of methods. we need to add a configure method, of course. We need to add a render content method that is required by our base class, which we're extending. And it will also call configure and render content here at the end of the constructor. Now, regarding the configuration, there's nothing we need to do right now. For the content we want to render, there definitely is work to do. Now, we have a very simple template here, and we could actually change this here in the index.html file to be a bit more complex, so that every project has a h2 tag, has a h3 tag below that, let's say, and also has a paragraph, so that we can output the title of the project, the number of persons assigned maybe, and then the description. And then here in app.ts, in render content, we just need to reach out to these different elements in our element, so to the h2 tag and so on, and then insert some content. So there we can reach out to this element, which is our rendered element, so which is our rendered li element. And in there we now need to select these different things. So we can use query selector h2 and set the text content here, let's say to this.project.title to render the title there. Of course, we should add an exclamation mark here to make it clear that we'll always get this element, which we know with certainty because it's part of our template. Well then, actually, we can just repeat this, but now look for the h3 tag. And there I want to output the number of persons, however, where people is the property name. However, I'll tweak this a little bit. Now for one, this here is a number and this one's a string. So actually I'll call to string here. But that's not the main problem. Actually, I want to tweak this so that it outputs more than just a number here. But I'll come back to that. First of all, let's repeat this one more time and query for the paragraph here and set this equal to this project.description. Now, again, I will tweak this later. For now, let's leave it as it is. And with that, we have a project item that should be rendered and that should then also set its content. So now we need to use the project item, and the place to use it is the project list, because that renders the list of projects. And there specifically, in render projects, this is where we need to make sure that we render our project items. Here we do go through all the project items in assigned projects, and assigned projects is this property here, which has a list of or an array of projects. So now here in this loop, instead of creating a list item manually and so on, I will get rid of all of that and simply say new project item here. And now to project item, we need to pass the ID of the host. Now that, of course, is the ID that was set on our list item here. So basically this.element.id, that's the ID of the host element, because this element, which is the unordered list, should be the host. Then, second argument here is the project, and that's purge item here, basically. So this constant which we get inside of the loop. And now the attachment will happen inside of project item or inside of the base class of the component class which project item extends, and instantiating project item should be all we need to do. So if we save that and we go back and we have this code here again, or we have this input again, you see this gets rendered and this doesn't look too bad. Now there are two things which I don't like. Of course, that bullet point here, not too fond of that, and just having the free here. I'm also not super happy about this. So how can we fix this now? To fix the bullet point, let's inspect our content, and what we see there is that the list item actually is rendered outside of the unordered list. So it's not inside of it. If it were inside, then it would work properly, but I can't drag it there. So we need to make sure it gets rendered inside of the unordered list. So let's find out why that's not the case. It's probably not the case because in project item, I pass false here to the base class constructor, and passing false here means it's not getting inserted at the start, and that in turn means that in attach, we have before end as a value here, where it's getting inserted. This is, however, what we want to have happen, so that's probably not the problem. Well, the problem still is that of course, we're inserting it in the host element. And now let's think again, what's the host element of project list? And that's in the end what matters here, because when we render our projects, we create a new project item, and I forward the ID of our element here, of the rendered element in the project list to project item. So that will then be the ID of the host element of a single project item. But what is this element here? This element here is not the unordered list we have in that box. It's the box itself. It's our section. If we inspect the template, we see the section here is what actually gets rendered for our project list class. It's not just the list. It's the section which also includes a header. So we actually need to get access to the list inside of our element here, and then get access to the ID of that list. Because here, we do actually set an ID on that list. So there will be an ID, we just have to grab the right one. So getting the ID of the element itself is simply not correct. Instead here, we should get the ID of the unordered list in our element. And we know with certainty that there will be an unordered list, so we can't skip the null check by adding the exclamation mark. Now with that added, if we add a new element here, this looks better. Now the bullet point is gone because now the proper styling is applied, since the li, the list item, is now really added inside of the unordered list, as you can see. Now that's one thing. Now let's move on to that 5, because just outputting a 5 here is not really what I want to do. How about outputting a bit more useful information? To output more useful information about a single project item, let's go to the project item class, because that is where we render this. And in there, when I set the content of the h3 tag, which is that number of persons, we could change this to say number of persons, which we're outputting here, plus assigned. So that we at least say, if I render this, 5 assigned. But 5 assigned also isn't really a good wording, right? Now, of course, we could say 5, or whatever the number is, persons assigned. So if we say persons assigned here, that is better. Whoops, testing. Does this work? Because now this says 5 persons assigned. Well, that's better, but it's still not optimal. What if we only have a project with 1 person? It still says persons, and that doesn't make too much sense. Now, a getter can help us there. So instead of saying persons or person here, I just say plus assigned, but actually I don't just want to output the number of people here. I want to use a getter instead, which returns us a proper term, so the right text basically. So here I'll add a getter, and convention, not a must do, but a convention you often see, is to add getters and setters right below your other fields. So I will add it here below my fields above the constructor. Now I'll name it persons. The name is totally up to you. I'll name it persons here, and a getter is basically like a function. So you have to add parentheses here and then curly braces. Now in there, as you see, you must return a value. And here I want to return a value, which is basically some text based on the number of people I have in my project here. So here I want to check if this project people is equal to 1. In that case, I will return 1 person as a text here. Else, I know it's more than 1 or 0, and in both cases I would say persons, plural form. I will return a template literal actually, simply because it's easier to write a text with injected content with a template literal. And there I'll say this project.people persons. So now this is the text I return in this scenario. So now we just have to use this getter to automatically get the right jargon, the right text. So down there, instead of reaching out to this project people, I will just say this person's assigned. And I access this like a normal property, so we're not calling this like a function with parentheses. Instead, we access this like this. But this will trigger this getter because it is the same name. So this will trigger this getter, run our logic there, and then return the appropriate text. So now if we try this again, testing, does this work? And I assign 5. We see 5 persons assigned. Does this really work? For sure. And I add 1 here, we see 1 person assigned. So now this works in the way I want it to work. Now this really outputs this properly, and it shows a nice use case of a getter, where this helps us transform data when we retrieve it. So let's now come to the end of this project, and that involves the possibility to drag and drop a project which we have in one of the 2 boxes, for example in the active projects box, into the other box. So to basically switch the project from being an active project to being a finished project. So it's also not just about the visual update, it's not just about dragging and dropping it and updating the UI, it's also about adjusting the data behind the scenes in our state management class. In the project state, where we manage a list of projects in the end, keep in mind that every project does have a status property, and we'll need to update that as well. So 2 things we need to implement: drag and drop, and then also this behind the scenes state and data update. Now let's start with drag and drop. And for that, we will basically implement drag and drop as we would do it in vanilla JavaScript, which you, for example, can learn about in my complete JavaScript guide. Basically, it's all about implementing a bunch of event listeners, and of course, you will see how it works in this module in the next lectures. But we'll implement it in TypeScript style, so we'll enhance it by using some TypeScript features. So let's get started. And how do I want to enhance it with TypeScript features? Well, I want to reuse interfaces here, drag and drop interfaces, but not just to define the structure of some objects as we previously used interfaces, but instead to really set up a contract which certain classes can sign to force these classes to basically implement certain methods that help us with drag and drop. To be precise, I'm thinking about 2 interfaces. And of course, using these interfaces will be optional, but this will allow us to, well, basically provide some code that forces a class to implement everything it needs to be draggable or to be a valid drop target, which, if we were building a bigger application, could help us write cleaner code and more understandable code, especially when working in a team. So, which interfaces am I talking about? I want to have 1 interface, which I'll name draggable, and I'll have a second interface, which I'll name drag target. My idea here is that we can add the draggable interface to any class that renders an element which can be draggable. In our example, that would be the project item class. The project item class is responsible for rendering, well, these project items, and these should be the draggable pieces. And the boxes, active projects and finished projects, so here our project list class, should be drag targets. Now, what do these interfaces force to be implemented or to be added to the classes then? Let's start with draggable. Here we basically need 2 event listeners and therefore 2 handlers for these events. A drag start handler, which will be a method, and a drag end handler. Because when implementing drag and drop, the thing which you want to drag will require some listener that listens to the start of that drag event, and also potentially a listener that listens to the end of the drag event, so that you can do any kind of updates there which you want to do. Now, the drag start event handler will get an event object which will be of kind drag event. That's a built-in type TypeScript ships with because of our tsconfig setup and the libs we're adding there. And it will not return anything. It will be a method which executes, but which then just does something, configures the drag event, for example, but does not return. Now the drag end handler gets a similar event. It also gets a drag event, and it also returns nothing. Now, of course, you will see how we apply those in just a few seconds, so bear with me. Now, what about the drag target? Well, for the target, so the box onto which we can drag something, there are 3 event handlers I want to implement. A drag over handler, a drop handler, and a drag leave handler. Now, what do these things do? Now, you need to implement a drag over handler when implementing drag and drop in JavaScript to basically signal the browser and JavaScript that the thing you're dragging something over is a valid drag target. If you don't do the right thing in the drag over handler, dropping will not be possible. You need the drop handler then to react to the actual drop that happens. So with the drag over handler, we'll permit the drop. With the drop handler, we'll handle the drop. And then here we can update our data in UI, for example. And the drag leave handler can be useful if we're, for example, giving some visual feedback to the user when he or she drags something over the box. For example, we change the background color. Well, if no drop happens and instead it's canceled or the user moves the element away, we can use the drag leave handler to revert our visual update. Now, all three handlers also receive a drag event and don't return anything. So let's update them appropriately like this. And also for this last handler here. And now we configured some interfaces which on their own don't do much, but now we can use them. And I want to start with the project item. So let's find our project item class for this. Here's the component, here's the project item. And now you might remember that an interface cannot just be used to define a custom object type, but that you can use it as a contract on a class. You can call implements or add implements here after your class name and after potential extensions you're doing, and then implement the interface, in this case, the draggable interface. Now, when you do so, and I just formatted this to bring it in a new line to make it easier to read, when you do so, you get an error now that the class here incorrectly implements the interface, because that draggable interface forces us to add two methods, if you remember. So let's add them here. Maybe we'll load a constructor. Let's add a drag start handler, which gets an event of type drag event. And let's also add our drag end handler, which receives our drag event. And now we have these two methods added. Now that alone does not enable drag and drop. It just helps us write draggable components or draggable classes in a uniform way. So if we add more and more classes which should be draggable, we always will have these methods, which simply makes it easier to reason about our code and to work our code, especially when working in a team, because everyone knows where to put in work for the drag start event. Now, what this does not do, of course, is listen to a drag start event. That's something we can do in the configure method, which we already have, though. We can reach out to our rendered element and add an event listener to it. And there, that would be the drag start event. The drag start event is one event, one default browser DOM event you can listen to. And the event handler we want to trigger, of course, is the drag start handler, at which we can point here. Now, we also want to be sure that inside of the drag start handler, that this keyword refers to our class. And as you learned with event listeners, that would by default not be the case. So we could use bind here and bind this, that would be valid, but we have a better way actually. We added our auto bind decorator, so I'm just going to add this here to the drag start handler. Now we can also listen to the drag end event here and point at the drag end handler. You can also add auto bind there if you plan on using the this keyword here. For the moment, I will just log drag end in here so that we see that it triggered, because here I actually have nothing specific I want to do with it, and therefore I will also blank this parameter and basically tell TypeScript that I'm not using it. Here in drag start we will use event, and for the moment I'll just log the event when this event occurs. Now that alone won't do the trick though. If you save everything and you add some project here, you'll see that you can't really drag it, right? If you try to drag it, that will not work, because you also need to change something in your HTML file. On this list item, which is getting rendered for every project, which is the thing we want to drag, you have to add the draggable attribute and set this to true. That is important. This tells the browser that this will be draggable. With that, if you save that, and you re-add a project here, you see now this indeed is draggable. It now is stuck to my mouse, and now we can really move it around here just fine. You also see on the right that a drag event fired when I started dragging. And if I let go, you see the drag end event also fires. So our listeners are connected and we can drag. Now we can work on the drop target. So on the box where this should be draggable to then add the project to that box. One thing I will also do real quick is in the app CSS file on the list item, so on projects LI, I will add a background color of white simply so that we can see this a bit better. So here, project LI, I added white so that when we do drag around the project here, we do have the white background here, so this makes it a bit easier to see. Doesn't change our next step though, we want to make this droppable. To make it droppable, we have to go to the class or to the component in our application, which should in the end act as a drag target. So here, project list class is the right class, and there we can implement our second interface which we added, the drag target interface. Now, just as the draggable interface, this forces us to add certain methods. To be precise here, we need to add the drag over handler, the drop handler, and the drag leave handler. So let's do that. Maybe also right here below the constructor above configure. But the exact place is up to you. The order of methods does not matter. So here I will add the drag over handler where we get our drag event. I will then add the drop handler here where we also get our drag event. And last but not least, the drag leave handler where we also get a drag event. Now, these events, by the way, hold different kinds of data, but they're all based on the same core event type. Now we get a couple of different things to do. Let's start with the drag over handler maybe. In the drag over handler, I want to change the appearance of my box or of the unordered list in there to visualize that this is a droppable area. Because right now when we drag around element, we get no clue of where we can drop it, right? Nothing changes on the UI, so I want to change this. To change this, I'll add a certain CSS class to the unordered list, which you find in app CSS, the droppable class, which will change the background color. And therefore in here, for a start, we just need to get access to our unordered list element. We can do so by reaching out to this element, query selector UL, and add an exclamation mark because there will always be an unordered list there, even if it holds no elements yet. We just have to make sure that the this keyword works here, and we can do so by auto binding this here to make sure that the this keyword is bound to the surrounding class. And then with the list element selected, we can use the class list property of DOM elements. So this is vanilla JavaScript here in the end. And call the add method there to add the droppable class to it. Now with that, we of course have to make sure that the drag over handler actually is fired when we drag something over this element here, over this rendered section. And to do that in the configure method, where we already have one listener here listening to our state changes, I will also register listeners on the element itself. The first event listener there, of course, is the drag over event, and I'll bind this to the drag over handler, unsurprisingly. And then I'll repeat this because I also want to listen to the drag leave event and bind this to the drag leave handler, and to the drop event and bind this to the drop handler because we'll also need that later. So with that, we got this drag over event listener and the drag over handler connected. But we also got some errors in the code now. Well, that should be the unused event objects here. So for the moment, to satisfy TypeScript, let's just blank them out. We'll need them later, but for the moment, to make this work, let's blank them out by using underscores here to tell TypeScript we're fine not using them at the moment. Now this compiles. And now back in the project, when we add a new project here and I drag this, you see when I drag this over finished project, the background here got light blue. Here over active projects, it got light rose, like a slight pink color. Just to show this again, if I reload, you see now we have white backgrounds in the projects. Whoops. And as soon as I start dragging, this here gets a light pink background. And when I drag it over finished project, the box background changes to light blue. Now it never changes back to white because we never removed that droppable class, but it is a first step. Of course, dropping still does not work. Dropping it here does not add the project because how would it? We haven't added any logic for this. So let's make sure to also update the styling when we leave the element. So when we basically drag it over here and then go away. Make sure that the blue background goes away in that case. That's what I want to do next. For that, we can use the drag leave handler here because that will fire whenever we, leave this element with our dragged element. And now there, I of course also want to get access to my unordered list. So I'll copy that code. But then there, I want to remove the droppable class. And we should now also auto-bind this so that the this keyword here refers to the surrounding class. If we save that, we add a new element here. Let's give it a try. If I start dragging, you see we have our background here. And if I leave, it goes away. So now the background really is updated. You see some flickering here because the drag leave event also fires if you go from having the mouse cursor over the background to having it over a rendered element. But that should be fine here. It's no big deal here. So actually we got the desired effect, I would say. So the UI is updated just the way it should now. But of course we're not able to drop and really transfer data. So that will be the next step. Visually, we are able to drag and drop, but technically in JavaScript, of course, our script has no idea of what's happening. To us humans, of course, it's clear that we're dragging this exact item here. But if we have a look at our code, how would JavaScript know what's getting dragged, where? How would we update our state based on the information we have right now? It wouldn't really be possible. So to make that work in JavaScript, we have to go back to the class of our draggable item, the project item. There, in the drag start handler, logging the event to the console isn't everything we should do. Actually, we don't need to do that at all. Instead, let's now use our event object here, because that has a data transfer property. This is special for drag events. They do have such a data transfer property. And on that property, you can attach data to the drag event, and you'll later be able to extract that data upon a drop. And the browser and JavaScript behind the scenes will store that data during the drag operation and ensure that the data you get when the drop happens is the same data you attach here. For that, you can call set data on data transfer, but data transfer could actually be null. So we have to add an exclamation mark here. We of course know that it won't be null here. You might wonder, why could it be null? Well, the drag event is always the same kind of event, but based on which listener triggers it or which exact event you're listening to, data transfer is not necessarily available. So not all drag related events give you an event object that has the data transfer object. The drag start handler, which fires upon the drag start event, however, does have it. So here we can safely call set data. And now set data takes two parameters, two arguments here. The first argument is an identifier of the format of the data. And there you got certain possible formats available. Attached, you'll find a deep dive into drag and drop with JavaScript, where you can learn way more about that. You'll also learn more about it in my JavaScript Complete the Guide course, by the way. Here we need the text/plain format, which means we're just going to attach some plain text as data that is transferred. And that's important. We're not going to attach our object here, our project itself, which is getting tracked. So not the concrete project which we rendered here. Instead, it actually suffices to attach the ID of the project, because this will later allow us to fetch that project from our state. So attaching the ID is all we need to do. We want to transfer only a small amount of data. This will also save us some memory. So now with that, we're attaching data to the drag event. One other thing I want to do is on data transfer, where we again have to add the exclamation mark, I'll set the effect allowed property to move. This basically controls how the cursor will look like and tells the browser a little bit about our intention, that we plan to move an element from A to B. An alternative could be copy, where you then get a different cursor, which indicates to the user that you're copying and not moving. But here I really want to move the element, which means upon a drop, we remove it on its original place and add it to the new place. So now data is attached here. Now that's step number 1. Let's now go back to the place where we want the drop to happen, which is the project list. There it starts in the drag leave handler. Now in this application, in this project here, we only have one drag and drop operation, and that is our projects here. In bigger applications, you might have different pieces on the page that can be dragged and dropped, and you don't want to make everything droppable everywhere. So therefore here in the drag, not in the drag leave handler, in the drag over handler, which fires when you enter a draggable area with an item attached to the mouse, I want to check if a drag really is allowed here. For that, I will check if event data transfer, here it is available as well, so if that is available, and if it is available, the data transfer types property has a first value which is equal to text/plain. That simply means, is the data attached to our drag event, is that of that format? Which it of course is, because that is the format we set up in the drag start handler here. So for example, here I would not allow dropping images or something like that, which would have a different data format. I just allowed dropping of plain text. Of course, I now also need to replace underscore with an event again, because I'm referring to it here. Now, if that is the case, then I know I want to allow a drop. So then I will update the background. And there's one other important thing we gotta do. You have to call event prevent default. Now, why do we have to call that? Because in JavaScript, drag and drop works such that a drop is actually only allowed. So the drop event will only trigger on an element if in the drag over handler on that same element, you called prevent default. You can think of this as the following. The default for JavaScript drag and drop events is to not allow dropping. So you have to prevent the default in the drag over handler to tell JavaScript and the browser that for this element, in this case for this section, for this project list class, you want to allow a drop. So only if you do this in the drag over handler, the drop event will actually trigger when the user lets go. Otherwise, if the user lets go, the drop event will not fire. So with that, the drop handler will then eventually execute, of course, because now we are allowing this to happen. So here in the drop handler, we now also can accept the event. And for the moment, let's just console log the event here, like this, to see whether this works. We now save everything, and we add a new item here, and I drag this. If I drop it here in finished projects, you see this drag event is firing here. And that's coming from line 236, which indeed is this line in the drop handler. Now, if we inspect the drag event here in the browser, you see we have a bunch of data in there, and we also have that data transfer property. And in there, you see the effect we allowed, which is move. And you also see nothing in there. Well, only because the data was already cleared after this was being printed to the console. And since we print an object here and objects are reference types, well, we see the latest snapshot where the data is lost. Actually, at the point of time we are dropping this, we will be able to extract data from data transfer. And I can prove this to you. Of course, we can simply access data transfer, and there you have a get data method. And now we want to get the data with this text plain format. And that should be the project ID we attached to our data transfer package on the project item. So if we now save this, and we re-add the project here, and drag this here, you see this here indeed is the item, is the ID of this project item. We can see that if we inspect it, because we also added here as an ID in the DOM, 0.2167 looks like this ID to me. So we are successfully transferring the ID. Now we're almost there. Now we just have to update our state behind the scenes and then re-render the UI. So of course our goal is not to just log that ID. Instead, I want to extract the project ID here in the log, in the drop handler. And with that, the goal is to really move the project now, or change the project status to be precise. Now, how can we do that? Well, in our state, I would say, in our project state, where we currently have an add project method, we also need a move project method. And the goal of this method will be to basically switch the status of a project. Of course, you could also therefore name it switch project status or whatever you want. But since we're doing drag and drop, I'm calling it move project. So in move project, the goal is to move a project from the list it's currently in to a new list. Now, this doesn't always mean that we just have to flip the project status from active to finished and the other way around. After all, a user could be doing this, drag and drop in the same box. So if we then always trigger a method that switches the status, we would have an unexpected effect where dropping in the same box still switches the project to the other box. So instead, in move project, we really have to know which project to move and which box the new box is, so which status the new status is. So I expect to get the project ID here, which should be a string, and the new status. And the new status here, of course, can be of type project status. And then inside of move project, I want to find a project with that ID in my array of projects. So here in this array of projects, and then flip its status. So for that, we can reach out to this project, find a project in there, and the find method is perfect for that. It runs on every element in this array, gives us access to every element, and then we have to return true if it's the element we're looking for. And I want to return true if the ID of the element we're currently looking at is equal to the project ID I'm getting as an argument here. Then we have the element which should change. And there on this element, we just have to change the status to the new status. Now this might be null. So here I'll call this project, store this in a constant called project, and check if project exists. And if it exists, then I want to set the status equal to the new status here. Simple as that. This will already change the object in the array, and we're basically done with it. Of course, however, we're not entirely done. We now need to let everyone know, all our listeners, that something changed about our projects and that they should re-render. So we have to go through all listeners again, and since we would repeat code here, I will outsource this in a new private method. Update listeners could be a viable name. And in there, I'll have this for loop where we go through all listeners and then do something. And then I will call this update listeners both from the add project and also from the move project method. Here only if we did change something. So now all listeners will be triggered. And if you remember, a listener in our app here basically leads to the list to re-render its items. So that will work exactly as it should, or it should work exactly as it should. So now we have that move project method. Down there in the drop handler, we can now use this. There we can now use the project state, call move project and pass in the project ID, and now the new project status. And the new project status depends on the list on which we drop this. So I want to auto bind my drop handler so that the this keyword in the drop handler refers to the surrounding class. And this surrounding class is a project list, which, if you remember, will have a type property here. We're storing it here. We're having a type property, and that is active or finished. So now we just have to translate active or finished to our enum values. So here I pass in this dot type, and I check if it's equal to active, in which case we pass in project status dot active as the new status of the project, because that is the status of the list we moved the project to. Otherwise, we pass in project status.finished. And let me reformat that to make it easier to read. With that, let's give it a try. Let's save all and add a new project here. And now drag it to finished projects. And it switches. And the same if I move it back. If I let go here in active projects, nothing changes. Now you will see if you inspect the DOM that technically it re-renders, which might not be ideal. So we could think about coming up with some solution which checks whether the status actually did change. And if it didn't, we don't update. That's something we can do. But from a UI perspective, it updates just as it should. Now let's also add a second project and see if that destroys something, if everything still works. And I would say that looks decent. That looks pretty good to me. Everything seems to work exactly the way it should. So dragging and dropping works just fine here, but there is this one improvement I mentioned back in the project state. In move project, when I call this update listeners, we can actually check if we did really change the status. So here we can check if project, so if we did find one, and if then project status is different from the new status. And only then we change the status and update the listeners. If the status is the same, we don't do this and we avoid the unnecessary re-render cycle. So now with that, if we save that and we quickly add a new project, you will see if I inspect the elements here and you watch the LI and check whether this flashes, which means it would re-render. It does not flash here, only droppable flashes, the class which is added, but the LI does not flash if I drop in the same box. It only flashes if I move it to a different box. And it should flash then, because then we really did move it. So now we optimize this a bit, and now we have working drag and drop here, all built and powered with and by TypeScript. And this is it for this little demo project. Now, of course, there's always more you could do, but here we're already using a bunch of nice TypeScript features you learned about throughout this course. And with this project, you hopefully have a better idea of when we use which feature, why certain features like decorators and interfaces exist, how they can help us, and how we can write type-safe, scalable code. Now, definitely feel free to build up on this project, add more features on your own, explore what you could change there, and simply practice working with TypeScript. I'm happy with the current state, and in the next module, I now want to tackle a quite obvious problem. We got one super huge file here. So splitting this up into multiple files would really help us with managing our code base. Because right now, if we want to change something somewhere, we always have to scroll through the entire file and find the place where we want to make a change. That's not ideal. This already is quite a lot of code. In even bigger projects, it would be totally unmanageable. So in the next module, we'll have a look at the features TypeScript gives us that help us with splitting our code across multiple files.